Hi, good morning, Raj. So, in this mock interview round, we are going to evaluate graph-based workflows, and we will be taking concepts on branching, chaining, conditioning, and merging. And we are going to, observe what kind of questions are coming across this category and what might be the gaps which are missing at our end, so that we can fix and we can proceed further. So, I'm going to get started with the first question. So, here, the first question.
How would you design a graph-based GenAI workflow with branching, chaining, conditioning, and merging for a multi-step enterprise support assistant?
Yeah, please go on.
Okay, so as a architect, if I want to design a graph-based GenAI workflow, means just instead of directly designing a architect, so I will be deep dive and I will be understanding the what is the uh, business complexity as well as what is the business expectation, what are the what are the systems, what are the systems we are going to enterprise systems we are going to touch, and I will be make a decision based on the requirements they want. So in case if I will be start designing a graph based on the uh, conditional routing, checkpoints, and uh, let's say dynamic or orchestration. So it will be based on the nodes and edges. So I will be designing planner agent such a way. I will put a planner agents to the planner agent will understand the intent of the user. Then in the planner agents will from there they will keep the I will make a state throughout the entire GenAI workflow to maintain a state. And that planner agent will decide which nodes to invoke. Uh, so then from there I will be maintaining the which branch to execute and how we have to maintain the merging from the each branching, and throughout the entire branching chaining I will be maintaining the state of the entire workflow they want. So likewise this way I will be designing the GenAI based multi-set enterprise support they want. So
Okay. Okay, let's get to the next one.
In that workflow, how would you decide branching conditions and merge strategy to balance latency, cost, and answer quality at enterprise scale?
so so the branching, when come to the branching conditions, it will be decided based on the each node or agents we get calling there. So in that each calling, so what needs to execute, so based on the which conditions it will be decided under uh, mm, edge level when come to merging. So at the end of the I will be maintaining as state across the nodes. So I will be fetching the node status from the state from the each node. From there, I will be merging it. So with this approach, I think I can able to balance the latency and the cost and answer quality. So each place with the state with the state I will maintaining, right. From there, I will be how the prompt I can optimize it, context compression. With all this, I will be considering it to balance the latency, cost, and answer quality.
Okay, let's get to the next one.
How would you troubleshoot a graph workflow when conditional branches produce inconsistent outputs after merging across parallel GenAI chains?
How would you troubleshoot a graph workflow when conditional branches produce inconsistent output after merging across parallel GenAI chains? Okay, so when come to troubleshoot graph API, so first I will be analyze the API's log, production log, as well as audit log. So where what are the exact issues where it is happening? So from there I will be start on diagnosing the each cases. So if I will understand from the log, so which node or edge got failure issue. From there, what is the from I will be debugging from the state. So from the like a CI/CD pipeline, what is the input and output for the each node, and what is the state are we maintaining? So throughout the graph flow, are we maintaining a state correctly or not? So is that each condition is executed properly based on the state, and what is the schema we have passed for the day each node, what is the expect or we get the expected output from the each node. So then as well as based on outputs are the LLM, the intent of the LLM is I've got the proper output or not. So these are things I will be key things I will be checking it there also.
What best practices would you apply to version, test, and govern complex graph-based GenAI workflows with branching, chaining, conditioning, and merging in production?
Okay, so as a architect, if I want to apply the version and test governance means, so version I will be using I will apply the semantic versioning. So throughout the project, I will be maintaining the semantic version, major, minor, patch. So with that, throughout the project, like each agent in each not each nodes, I will be maintaining the version. For testing, I will be separately maintaining. I will be using separate tools for to define. I will be define the test cases. I will be testing it. When it comes to the governance, so entire flow, I will be applying proper, let's say, security governance, data governance, as well as compliance governance, whether to handle when it comes to security, we have handled uh, uh, access based whether role based or attribute based access. Are we having a proper authentication or authorized person, as well as data, whether it's a DPL masking, data masking, and encryption. These are the governance based. I will be taking care of this one, Devanshu.
Okay. Okay.
How would you evaluate and optimize state management across nodes in a graph-based GenAI workflow to ensure reliable branching, chaining, and merging outcomes?
Mhm. Oh, no idea. I know the evaluation automation, I know, but when it comes to the branching, chaining, and merging, with combination of answers, I'm not sure, Devanshu.
Okay. Any idea about how to track state consistency in order to manage states?
Yeah, when it comes to the state consistency, as I said, uh, so as whenever the user sends a query, so the model will, the planner agent or router agent will understand the intent of the query, and I will design such a after understanding intent, I will maintain a state of that state of that flow. I will throw across the each nodes they want. So it will help us to what is the intent. Suppose if I want to make a book a ticket, for Mumbai to Chennai means so the ticket once the planner agent is so the ticket number so throughout the all nodes I will be maintaining what is the state of the tender flow so that will help us to maintain to track so each between the each nodes flow with that with that each node know what needs to do and what needs to track also.
And how do you implement atomic states using, let's say, distributed state stores?
No idea. No idea, Devanshu.
Okay. And uh, any information across how can you synchronize state access in parallel branches?
No, because the graph API I haven't worked on. I have these concepts are new to me, Devanshu.
Okay. Okay. Let's get to the next one.
How would you design fallback and recovery paths in graph-based GenAI workflows when a branch fails, times out, or returns low confidence outputs?
Okay, so in these scenarios of our each, whenever the graph-based model fails, I will be properly involving the retries. As of retries, suppose in any of the nodes get failed, any so I will be validating again for each nodes. What is the response? Whether is there any error? Means I will be retry once. If there is no expected answer, if there is any error, I will be retrying it. So whenever a branch fails, so it is also the I will retry once, and if any time I will wait for the particular timeout. Then I will be retry it once. If there is any low confidence or if it is any high risk one, I will be validating once, and it will be fractured. I will be doing. I will be involving a human in the loop with the proper uh, access validation in place there also. So I think these are the key things I will be designing in the fallback and recovery reports.
And can you also explain how can you dynamically update recovery strategies in order to maintain workflow resilience?
How can you update dynamic?
How can you dynamically update recovery strategies to maintain workflow resilience?
So yes, to update the dynamic, so I will be update each state and I will update the state of the each nodes there also. So with the each state and the status, what is the current progress? With this, we can track back where are we currently processing it.
Okay, let's get to the next one.
How would you measure and compare branch level effectiveness in a graph-based GenAI workflow and use those insights to refine routing, merging, and orchestration decisions?
No idea, Devanshu.
Okay, let's get to the next one.
How would you architect human-in-the-loop checkpoints within graph-based GenAI workflows to govern critical branch decisions, escalations, and final merged outputs?
So if I want to design a human in the loop checkpoints in this scenario, so it will be I will be decide based on the risk. Whether if it is a low risk means I will be directly give I will be directly sharing response to the end user. So if it is a high risk, then I will be design such a way to involve the human in the loop with the proper role with the least privilege and role-based access users. I will validating whether is that your user has the proper access and to role proper role is enabled to review or approve with this one. Devanshu. So let's say assume if the user is want to if a finance inquiry is doing it. So if the accuracy. If the risk is high, means I will be routing it to the, if the user has to be a finance role, then I will be routing it the respective users with the proper validation checks in place. Devanshu.
Okay.
How would you validate and debug conflicting outputs from multiple graph branches before merge, while preserving traceability, determinism, and business rule compliance?
No, Devanshu, no idea.
Okay, let's get to the next one.
How would you design reusable subgraphs and dynamic routing policies in complex GenAI workflows to improve scalability, maintainability, and controlled evolution across enterprise use cases?
So as an architect, I make sure to design the each nodes like a subgraph. It only it will has to so I will design such a way to common schema, the input schema for all the agents. So across the agents, I will be defining a common schema where where I will be maintaining a state. So if we based on the each state, the nodes of that from each respective GenAI, the graph-based solutions will decide. So I will maintain a schema for entire graph flow. Will maintain the same schema. With the schema, I will be the parameters. I will be passing the different parameters because each for each schema, if we may for each nodes, if we maintain a different schema, it will be difficult to understand. It will be difficult to maintain the scalable and maintainability. So throughout the flow, I will be for each nodes, I will be maintaining a same schema. The inputs only will get changed. So I once the nodes receive that schema, I will be validating it whether the input parameter received as expected or not. So if it is expected input received, I will be processing the rest of the next steps. If not, I will be providing a proper error code, error status, and I will be processing for next steps. I think like this, I will be designing the reusable subgraphs.
Okay. So how can you, ensure in order to implement subgraph evolution, or how you can do these standardized interfaces for compatibility? How can you ensure and implement that?
Mm, no idea, Yavancho.
Okay, let's get to the next one.
How would you ensure observability and root cause analysis across graph workflow branches, conditions, and merges in production GenAI systems?
Okay, so for observability, I will design observability such a way to trace what is the trace ID, what is the user intent, what is user query, what is the intent of the from the LLM understood from the user query. So from there, what is the I will be tracing each level of the information from the flow, Devanshu. Like if the from the intent, so what is the node is triggered, what is the for each node, what is the state we have maintained it, what is the memory we have maintained, what is the memory we are maintaining it, we are maintaining a, if we are having a maintaining a different memory, working memory, session memory, long term memory, what is the memory details, and post that what is the nodes, the graph is triggered, what is the nodes and what is the edges, what is the conditions is matches. It will be provided. I will be tracking all those things along with what is the model So LLM models, input and output tokens, what is the latency, so what is actually these are things I will be tracking it as part of the graph workflow, Devanshu.
Okay. And how can you use distributed tracing to follow workflow execution paths and correlate events? How can you do that? So you have to explain distributed tracing. So the question is, what is distributed
Distributed
tracing?
trace.
Yeah, and how you can use distributed tracing to follow workflow execution paths and correlate events happening.
Okay. So as I said, I will be maintaining the state-based session state-based uh, memory, Devan. So with that memory, I will be for each node call and edges call, I will be updating the session state in our each flow. It will help us to tracing for the each node calling and edge conditions going invoke, right? So with that, we can trace it. It will be conditionally it will distributed the trace information, Devan. Automatically each node will understand what is the state, what are the next needs to execution from the session state, from it will be invoke accordingly.
Okay. Okay. Let's get to the next one.
How would you benchmark and stress test graph workflow branching and merge logic under changing traffic, model drift, and policy updates without breaking downstream chains?
I have no idea, Devanshu.
Okay. Let's get to the next one.
Well, most of topics here, most of questions are will be new for me.
How would you design guardrails and policy-aware routing in graph workflows so branches adapt safely to sensitive inputs before deterministic or learned merges?
How do you design guardrails on a policy about routing? So as architect, so throughout the graph system, I will be designing. I will be considering the proper guardrails as well as routing. Whenever the user enters the query, the API gateway routing with the proper uh, access and authorization will be checking in the routing, and it will be route to uh, the model. The model will in turn, whenever I send their in their context to the model, I will be applying a guidelines to mask any of the PA data will be there. Anything, suppose if you are logging into any PA information, there also I will apply the guidelines like encryption and masking the data. So so once whenever the routing agents will understand the intent of the query, and it will route to the respective nodes. So the in the routing we'll be adding the input schema. Once the route when the routing reaches the respective nodes, so nodes will accept that schema, and I will be applying a validations against each schema. So validates against the guardrails. So are we it's the expected input we received or not? Um, so that with this safely we can invoke, and the rest of the flows will get executed with the proper validation routing. With that I can send the sensitive inputs, Devanshu.
Okay. Let's get to the next one.
How would you choose between deterministic and learned merge strategies in graph workflows, and what evaluation criteria would guide that choice for enterprise GenAI systems?
Inside, Devanshu, no idea.
Okay. Let's get to the next one.
How would you design and evaluate loop control in graph-based GenAI workflows to prevent runaway recursion while preserving adaptive branching and convergence quality?
No, these are the new concepts.
Okay. Okay. Let's get to the next one.
In a graph workflow, how would you evaluate conditional routing accuracy and branch convergence quality when multiple branches rejoin under latency and cost constraints?
No, Devanshu. No idea. I guess rest of questions also will be same only.
Let's get to the next one.
How would you version and safely roll out graph workflow changes affecting branching conditions, chain dependencies, and merge logic across enterprise GenAI environments?
No, Devanshu, when it comes to the version, I said throughout the GenAI graph-based system, I will be maintaining the semantic versioning. So now, all the entire project, whether we are having a prompt or nodes and wherever it's required, I will be maintaining a semantic versioning like a major, minor, and patching versions. Through the deployment also, I will be passing that the version number to match the which deployment version we are deploying it there also.
Okay. Okay. Sure. Let's get to the next one.
How would you design state management across branching and merging graph workflows to preserve context consistency, ID impotency, and recovery in enterprise GenAI orchestration?
Okay. So I believe the entire graph-based GenAI system will work based on the state management and one. So whenever the the intent and model is understand the user intent, from there I will be designing to maintain the state from the across the all nodes and conditions. So it will work based all nodes and whenever the node invoke is required, so the LLM will update once understand the intent, and LLM will update the router agent will update the what is the state management. So what is the intent from there? It will invoke the respective nodes and nodes. Then from the nodes will check the state management. So it will it will do the respective actions. Once it is done, it then each nodes will update the respective input, respective output. Then accordingly, the respective edges will continue their actions they want. So with this, I think proper each nodes will closely look around the state management, and it will be read and update on across the entire flow they want. So with this consistency update, the with this consistent update in all the nodes, the entire graph API will the will work as expected, as expectedly they want. So with this each with this update, I can if any failures is there, if any duplicate updates is there, where I can avoid the item potency, as well as if I will maintain the transaction based process. I will be revoking the transaction if any failures will occur. So I will be checking the duplicate entries before executing it. If any failures will occur, again I will be checking the duplicate whether the duplicate entries is there or not to avoid item potency.
Okay. And how can you implement version snapshots for let's say recovery and callback? Instead of callback, you can consider it as rollback.
Okay. So that's what in entire process, if I will be doing a process way of transaction based. So if in the transaction any failure will occur, I will be rollbacking, and it will roll back to the previous state, Devanshu. So proper error logging, and I will be revoking it.
Okay. Let's get to the next one.
How would you design fallback and recovery paths in graph-based GenAI workflows when a branch fails, times out, or returns low confidence outputs before merge?
I don't know idea.
Next one.
Sorry?
I mean, are you answering or
No, I have no idea on this one.
no idea? Okay, let's get to the next.
How would you evaluate parallel branch execution strategies in graph workflows to balance latency, cost, dependency ordering, and merge reliability for enterprise GenAI orchestration?
No, Devanshu, no idea.
Okay, let's get to the next one.
How would you evaluate graph workflow correctness when branches share mutable context, causing race conditions and inconsistent merges across chain GenAI tasks?
No idea, Devanshu.
Okay, the next one.
How would you evaluate human-in-the-loop checkpoints within graph workflows to improve branching decisions, escalation logic, and merge quality without creating operational bottlenecks?
No idea.
Okay, let's get to the next one.
How would you evaluate graph workflow resilience when upstream branch outputs are partially missing, conflicting, or stale before a downstream merge?
Sorry, Devanshu, no idea.
Okay,